In the last video, we discussed about equations of motion for uniformly accelerated motion and what is meant by instantaneous velocity and instantaneous acceleration. That already we discussed. Here, now we are going to discuss about the expression for the distance travelled in the nth second of motion. So what is meant by distance travelled in nth second of motion? For example, if an object is under uniform acceleration, at each and every instant of time its velocity is changing. No, velocity is changing. So the distance travelled during first second will not be same as the distance travelled during second or distance travelled in the third second. So we are finding the expression for the distance travelled in the nth second of motion. Okay. Distance travelled in the nth second of motion. Distance travelled in the nth second of motion. Okay. So an object covers, here we are dealing with only motion in a straight line. It is, we are bothering about only the object moving in a straight line. Okay. So if we are displacing distance and displacement, it will not affect because the object is moving in a straight line. In that situation, distance and displacement both are equal. Okay. So we are considering an object moving with an initial velocity u is the initial velocity, and Sn is the total displacement in n seconds. Sn minus 1 is the displacement in n minus 1 seconds. N minus 1 seconds. So we have to find the distance in nth second of motion. For example, an object covers some distance. In 100 seconds it covers 10 meters. In 50 seconds it covers, or in 95 seconds it covers something, it will be given. What is the distance travelled in that particular time? How to find? So we can write, if we are writing Sn, we know the equation S equal to, what is the equation? S equal to ut plus half a t square is the expression for the displacement of the object during a time of t seconds. In 10 seconds, what is the displacement if it is asked? Or in 5 seconds, what is the displacement it is asked? We can use this equation. S equal to ut plus half a t square. Okay. So, distance travelled in n seconds or displacement of the object in n seconds can be written as Sn equal to. So, instead of t, we can write it as n. So, what we will get? Un plus half a n square. Un plus half a n square is the displacement of the object in n seconds. Now, what is the displacement of the object in n minus 1 seconds? That can be written as Sn minus 1 is equal to u into n minus 1 plus half a n minus 1 square. So here instead of t, in first equation we are substituting as n, and in second equation instead of t we are taking it as n minus 1 because that is the displacement in n minus 1 seconds. Now what we have to find? We have to find the distance travelled in the nth second. So that can be found out as Sn minus Sn minus 1. In n seconds it travels this much displacement. In n minus 1 second this much it travels this much distance. So what is the distance travelled in nth second? That is given by Sn minus 1, that is equal to Un plus half an square minus Un minus 1 plus half an minus 1 square. Okay. We can simplify it. So what we will get? Un plus half an square minus. First of all, we can remove the brackets and here n minus 1 whole square can be expanded. But we will get Un minus u plus half a into n square minus 2n plus 1. Or we can write it as Un plus half a n square minus, bracket can be removed. Before that, once again we can simplify that. But we can write half a n square, half and 2 will get cancelled. So you will get it as minus a n, then plus a by 2. Half a into n square, half a n square, half a into minus 2n. 2 will get cancelled, you will get it as minus a n plus a by 2. Now you can remove the bracket. Un plus half a n square minus un plus u minus half a n square plus a n minus a. Okay, so un will get cancelled, half a n square will get cancelled. So which terms left? We will get it as u is left and here one a n is left. U plus a n minus a by 2, or this can be written as u plus a into n minus a. So the distance travelled in nth second of motion can be known as u plus a into n minus 1. So to find the distance travelled in nth second of motion, which are the quantities needed? Initial velocity is required, acceleration is required, and which time, whether it is 10th second, 5th second, 4th second, that time also needed. If you know that time, you can find the distance travelled in the nth second of motion for uniformly accelerated motion. Is it clear? Understood? No? And now we will discuss about graph. Different types of graph we will discuss. Okay. So we will start with position time graph. Okay. Position time graph. Position time graph. Okay. So we will start with the position time graph of an object which is at rest. So first case, stationary object. Stationary object. Okay. So we will discuss the position time graph of a stationary object. Position time graph of stationary object. So what is meant by stationary object? An object which is at rest. So what will happen to the position? Whether its position will be changing? No. No chance that its position will be changed. No. So if we are plotting the position time graph, we will get a straight line parallel to time axis, y I, because at each and every instant position remains same. At t is equal to 0 second, this is the position. At any instant of time, position remains same. So position time graph of a stationary object will be a straight line parallel to time axis. Okay. And next we will discuss about object moving with uniform speed. Object is moving with uniform speed. So if the object is moving with uniform speed or uniform velocity, what happens? The position will be gradually increasing. No, at equal interval. What is meant by uniform speed? At equal intervals of time, equal change in position will be there, or equal displacements will be covered, or equal distances will be covered. No. So if we are plotting, so we will get, here we are marking position and time. So the position time graph will be a straight line, inclined to both axes. Okay. Position time graph of an object moving with uniform speed will be a straight line, inclined to both axes, so that at equal intervals of time, if you are considering equal intervals of time, you can see that equal change in position. At equal intervals of time, equal change in position will be there. So we will get a straight line inclined to both axes. Okay. This is about uniform speed, if the object is moving with uniform speed. And from this graph, we can find the speed of the object. So how to find the speed of the object from position time graph? So our position time graph is given. Position, it is marked meters or kilometers, depending on the problem it will be given. And time, here it is, the graph is like this. How to find the speed or velocity? Okay, so here speed or velocity we can find. How we can find? We can draw a straight line perpendicular to the time axis, and we can mark it as OA. So what is meant by speed? Speed is equal to distance by time. No? Distance divided by time. So here distance is plotted along y-axis, so we can write AB by AB divided by time. Okay, speed is equal to AB by AB. Okay, or we can say that speed is equal to slope, or slope can be written as tan theta. If theta is the angle made by this line with the time axis, we can write speed is equal to slope, and that is equal to tan theta. Okay, is it clear? Understood? No. So this is the way of finding speed or velocity. Either it will be position or distance, whatever it is marked, not a matter, since the object is moving in a straight line. I told you speed and velocity will be same. So here we can find by the slope, or you can draw a straight line perpendicular to time axis. You can measure this distance, this length and this length, so AB by AB. Sometimes in graph they will give like this. X times 2-3 graphs will be given. Okay. And it is asked which is having more speed. 3 graphs A, B, C are given. Which is having more speed. So it is very easy to find whichever is closer to position, whichever is closer to the position axis, that line will be having more slope and it will have more speed. Okay, because this angle is more, no? This angle is more than this angle and this. No. So we can say that speed of A is greater than speed of B, greater than speed of, okay. So whichever line is closer to the position axis, its speed will be more, and you can write, how will you give the justification? You can write slope is equal to tan theta and angle is theta is more for A than B or C. Okay, so this is the position time graph of an object moving with uniform speed. Now what will be the case if it is moving with uniform acceleration? Of position time graph of an object with acceleration, with uniform acceleration. So if the object is in uniform acceleration, the position time graph will be a parabola, a curve. Position time graph will be a curve. Okay. This is known as parabolic shape that you will study in maths in detail. So at present you can come to know that you can understand that the position time graph is a curve. It will not be a straight line parallel to time axis, or it will not be a straight line inclined to both axis. It will be a curve. Okay. Is it clear? I hope all of you understood. Next we will discuss about velocity time graph. Okay. Equations of motion. Okay, we will discuss the velocity time graph. Velocity time graph. Velocity time graph. So is there any meaning to say about the velocity time graph of an object at rest? No meaning at all. Why? If the object is at rest, there is no change in position. If there is no change in position, no velocity at all. So no need to bother about the velocity time graph of an object which is at rest. Now we will consider velocity time graph of an object. Moving with uniform velocity. Uniform velocity. Velocity time graph of an object moving with uniform velocity. So what is meant by uniform velocity? In equal intervals of time, equal change in velocity will be there. Equal change in displacement will be there, or we can say that velocity remains constant. So if the velocity is constant, if we are plotting the velocity time graph, what will be the shape of the graph? We are plotting, I told you, whenever we are plotting, time will be plotted along its axis, and the other quantity, whatever it is given, that we have to plot along y-axis. Uniform velocity. Uniform velocity means velocity is constant. Velocity is constant. So the graph will be a straight line inclined to both axes. Velocity is constant, so that at equal intervals of time, if you are considering equal intervals of time, there will be equal change in, here we are dealing with object is moving with uniform velocity, so here velocity is constant. If the velocity is constant, what will be the shape? It will be parallel to time axis. Velocity remains constant. Okay, so this is the case. Velocity is constant. If velocity is constant, there is no change in velocity. Just now I told you. Velocity remains same. Okay, and next case of an object moving with uniform acceleration. Moving with uniform acceleration. velocity time graph of an object moving with uniform acceleration. So here acceleration constant. Here uniform acceleration means acceleration remains constant. So equal change in velocity in equal intervals of time. So the graph will be, here we are plotting velocity and here we are plotting time. The graph will be inclined to both axes. Okay, is it clear? So this is the case if an object is moving with uniform acceleration. And here what is the initial velocity? Initial velocity is 0. It is starting from the origin. No? So initial velocity is 0. And if initial velocity is not 0, what happens? If initial velocity is not 0. If we are plotting the graph, what we will get? We are plotting velocity versus time. So here initial velocity is not 0, so it will start somewhere on the velocity axis. Initially, at t is equal to 0, velocity is not 0, it has definite time. Okay, so these two graphs corresponding to positive acceleration. Why it is positive acceleration? Here in both graphs you can see that as time increases, what happens to velocity? Velocity increases. Okay, so these two graphs corresponds to positive acceleration. And if it is negative acceleration or retardation, what will be the graph? Velocity should decrease. No? So for retardation means negative acceleration. No? So for retardation, what will be the velocity time graph? Velocity time graph will be, velocity we are plotting here, time we are plotting here, the velocity will be gradually decreasing. Okay, so that corresponds to retardation. So for positive acceleration, velocity should increase, and for negative acceleration, velocity should decrease, and for constant acceleration, uniform velocity means acceleration is constant. In that case, it will be a straight line parallel to velocity time axis. Okay, is it clear? And now we will discuss about equations of motion from velocity time graph. Okay, discuss about equations of motion for uniform acceleration. Equations of motion for uniform acceleration. Equations of motion for uniform acceleration from velocity time graph. Okay, so we are getting those equations from velocity time. So we'll start with velocity time graph of an object moving with uniform acceleration with non-zero initial velocity. So already we discussed the graph will be velocity time graph is inclined like this. No? Velocity time. Okay, so graph is inclined, initial velocity is not 0, it is having some value. Okay, so an object is moving with a non-zero initial velocity and with a uniform acceleration. So graph is like this, already we discussed, and from this graph we can obtain the three equations of motion. P is equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. How we can obtain that we will discuss now. Okay, so here we can mark first all those things. So a, here we are marking. Okay, C, B. Okay, So one important property of velocity time graph is that the slope of velocity time graph gives acceleration. Okay. We can write slope of velocity time graph is acceleration. Okay. Slope of velocity time graph is acceleration. And what is meant by slope? Just now I told you, slope is equal to the tan of the angle made by that line with the horizontal line. So that is known as slope. So we can write slope is equal to acceleration. No. And slope can be written as tan theta. So we can write tan theta is equal to acceleration. Okay. Now, how to find the acceleration tan theta? So what is OA? OA is the initial velocity, and what is OB? OB is the final velocity, and what is OD? OD is the time taken. So we can write all those things. OA is the initial velocity. No. Initial velocity, that is equal to U, and OB is the final velocity V, and OD is the time taken. Time taken. Okay. Is it clear? And we can write this, we can mark it as E also. Okay. So we can write tan theta is equal to A, and how to find tan theta? Tan theta is equal to opposite side by adjacent side. So we can write CE divided by AE is equal to acceleration. Opposite side divided by adjacent side. And CE can be written as CD minus ED. No. CD minus ED divided by AE, that is equal to acceleration. And what is CD? CD can be written as OB, and ED can be written as OA. We can write OB minus OA divided by OD, that is equal to acceleration. And what is OB? OB is the final velocity already being written. OA is the initial velocity. So we can write V minus U by T is equal to A, or we can write V minus U is equal to AT, or V is equal to U plus AT. So we got our first equation. First equation we got from the graph, that is velocity V is equal to U plus AT. Okay, is it clear? I think all of you understood, no? Now we will discuss the second equation. The second equation of motion, we can write the area under velocity time graph. Velocity time graph gives displacement. Area under velocity time graph gives displacement. Okay. And how to find the area? Area under velocity time graph gives displacement. So here we have to find the area OACB. No. Area of the corresponding to this line, area under this part will be the displacement. So we can write area of OACD, and that we can divide into two parts, one rectangle and one triangle. No? So we can write displacement S equal to area of rectangle, OAED plus area of triangle ACD. Area of triangle ACD. And what is the formula to find area of rectangle? Length into breadth. So we can write OD into OA. No? So we can write OA into OD plus area of triangle can be found out half into base into height. So we can write half into AE into CD. Half into CE into AE. And already we discussed CE can be written as, how CE can be written as CD minus ED or OB minus OA, that is equal to B minus O. And AE is equal to OD, that is equal to. So that we can substitute here. So what we will get? OA into OD. OA is U, OD is T plus half into CE can be written as B minus U and AE can be written as T. And from first equation we can write B minus U is equal to AT. B is equal to U plus AT or B minus U. B minus U is equal to 80, that we can substitute here. So what we will get is equal to UT plus half 80 into T, or we can write is equal to UT plus half AT square. This is our second equation of motion from graph. Is it clear to everyone? So very simple, only we have to find the area. Area formula you know? No. Area of rectangle plus area of triangle. By using that, we can find the displacement. Okay. And now we will discuss how to get the third equation of motion. Okay. Third equation of motion, how we can. So here also we can find the third equation by the same property. Area under velocity time graph gives displacement. Same property here we are using. Only one difference is that in the previous case we considered it as one rectangle and triangle. Here we are considering it as one rhombus. We can consider it as a rhombus. Not rhombus, we can consider it as a trapezium. So we can write displacement is equal to area of trapezium OACD. Area of trapezium OACD. And that can be written as, what is the formula to find area of trapezium? Half into sum of parallel sides into height. So we can write half into CD plus OA, they are the parallel sides, and height can be written as OB. Or we can write is equal to CD can be written as OB. No. So we can write half into B plus U into T. Again from first equation we can write B minus U is equal to 80, or T can be written as B minus U. In the previous case we substituted for B minus U, and here we are substituting for T. Okay. So T is equal to B minus U by V. So if you substitute here, what you will get? Half into V plus U into V minus U by V. Or you can write is equal to V square minus U square by 2A. And cross multiply it, we will get 2AS equal to V square minus U square. Or we can write V square is equal to U square plus 2AS. So this is our third equation, v square equal to u square plus 2as. Okay, is it clear? So today we discussed about the expression for the displacement or distance travelled in nth second of motion, discussed different types of position time graph, velocity time graph, and how we can obtain equations of motion from velocity time graph. I think all of you understood, and if you are having any doubt, you can contact. Thank you.